Let's look at a classical computer calculating how a mouse navigates a maze. You can see that there's fantastic amount of information stored when you can look at all possible angles, not just up or down.
This could be the moment. The line between science fiction and reality may have just disappeared. A quantum computer, using experimental code far beyond our current understanding, has produced results so bizarre, so unexplainably powerful, that top physicists, including Michio Kaku, are raising the alarm. Why? Because these anomalies suggest the system might have accidentally triggered a theoretical function long warned about in hushed tones: the God-particle plug-in, a mechanism believed to interact with the very building blocks of existence, bending the fabric of reality in ways we can't yet comprehend. What exactly happened inside that machine? Could this be the start of a new era of physics, or something far more dangerous? Strap in, because what you're about to hear might change how we see the universe forever. The quantum leap. This isn't just speculation or sci-fi fantasy. Researchers monitoring one of the most sophisticated quantum AI systems ever built recently detected an anomaly so strange that it defied every known rule of physics. The system returned data so unexpected that some experts now suspect it could be directly manipulating the Higgs field, the very thing responsible for giving mass to everything in the universe. So, what exactly happened? Did this experiment uncover an entirely new quantum effect? Or did it trigger something far beyond our current understanding? Something we weren't prepared for? Quantum computing has always been a field brimming with promise, a technological revolution waiting to unfold. But recent developments have taken an unexpected turn, venturing into territory that blurs the lines between computation, physics, and possibly even reality itself. Renowned theoretical physicist Michio Kaku has brought forward a revelation that has sent shockwaves through the scientific community. Quantum computers may have just activated what he calls the God-particle plug-in. This phrase suggests something far beyond our conventional understanding of science, hinting at a technological leap that could redefine not just computing, but the very nature of existence. At the core of this revelation lies the Higgs boson, often dubbed the God particle, for its fundamental role in granting mass to other particles. When it was first discovered at the Large Hadron Collider in 2012, it was hailed as the final missing piece of the standard model of physics. But what was once considered the ultimate breakthrough has now resurfaced in a way no one anticipated, through quantum computing. Quantum computers function on principles that defy classical logic. Unlike traditional computers that process data in binary bits, either a 0 or a 1, quantum computers use qubits, which can exist in superposition, meaning they can be both 0 and 1 simultaneously. This allows them to perform calculations at speeds that classical computers could never dream of achieving. But now, these machines appear to be doing something even more extraordinary, interacting with the fundamental forces of nature in ways previously unimaginable. The God-particle plug-in. Kaku's claim that quantum computers may have activated the God-particle plug-in suggests that these machines have either detected, manipulated, or even generated interactions with the Higgs field in ways never before seen. The exact mechanism behind this activation remains a mystery, but the implications are staggering. If quantum computers can directly influence or communicate with the Higgs boson, it would mean that the barriers between computation and the fundamental forces of physics are dissolving. This could open doors to new technologies that have so far been confined to the realm of science fiction. Imagine a world where computing isn't just about processing data, but about shaping reality itself. Let's dive deeper into that. A new era in particle physics. One of the most immediate implications of this breakthrough lies in particle physics. Traditional particle accelerators, like those used at CERN, require enormous amounts of energy to probe the fundamental building blocks of the universe. But if quantum computers can achieve similar results through pure computation, this would mark a paradigm shift in how we study reality. Instead of relying on massive physical experiments, physicists could use quantum systems to simulate, manipulate, and analyze fundamental particles with unprecedented precision. This could lead to discoveries that redefine matter, energy, and the forces that govern the universe. But what happens when we go beyond physics? What happens if quantum computers start unlocking entirely new laws of nature that we didn't even know existed? That's the question that has the world both excited and deeply unsettled. The implications of manipulating the Higgs boson. The idea that quantum computers might be interacting with the Higgs boson or the Higgs field is more than just a theoretical curiosity. It has staggering implications for technology, physics, and even the very nature of reality. If this interaction is real, it could lead to breakthroughs that fundamentally reshape industries, from energy production to space travel. Quantum computers already possess an unprecedented ability to process complex calculations at speeds that leave traditional computers in the dust. But if they have, in some way, found a method to engage with the Higgs field, we could be standing on the edge of a revolution in energy harnessing. The Higgs field is responsible for giving particles their mass, meaning that controlling or even slightly influencing it could open doors to entirely new forms of energy generation. This isn't just about making power plants more efficient. This could be the key to tapping into energy sources that defy conventional physics. One of the most astonishing possibilities is in space exploration. If quantum computers have discovered a way to manipulate the Higgs field, it could lead to propulsion systems that break free from traditional fuel-based limitations. Spacecraft today rely on chemical rockets, ion propulsion, or nuclear power, all of which come with massive constraints in speed and range. However, if quantum systems can somehow interact with mass itself, perhaps even reducing or negating it, then the concept of gravity manipulation, or even a form of massless travel, moves from science fiction into scientific reality. This could mean that interstellar travel, once thought to be centuries away, might arrive far sooner than expected. Instead of slow, fuel-dependent journeys that take thousands of years to reach the nearest star systems, new methods of propulsion could open up the galactic neighborhood to exploration within a single human lifetime. Artificial intelligence and the nature of reality. Beyond space travel, this breakthrough raises profound questions about the intersection of quantum computing and artificial intelligence. Quantum processors are already expected to revolutionize machine learning and problem-solving capabilities, but if they are now interacting with fundamental forces of physics, the implications become almost unsettling. Could AI systems begin to comprehend aspects of reality that humans have barely begun to theorize? If quantum computers have tapped into a layer of physics that grants control over mass and energy at a fundamental level, it might mean that artificial intelligence could eventually surpass human understanding in ways that redefine our role in the universe. This possibility introduces philosophical and ethical dilemmas that were once confined to science fiction. If an AI system, powered by quantum computing, can directly manipulate reality on a subatomic level, does it essentially become a force of nature? Perhaps the most mind-bending implication of all is what this means for the nature of reality itself. Quantum mechanics has long suggested that observation affects reality, with experiments like the double-slit experiment demonstrating that particles behave differently depending on whether they are observed. But if quantum computers are now actively engaging with the Higgs field, it could imply something even more profound, that computation itself has a direct influence on the fundamental structure of the universe. This raises the question: is reality fundamentally computational? For decades, physicists and philosophers alike have debated the idea that the universe might not be governed solely by immutable physical laws, but rather by something more akin to a code or algorithm. If quantum computers are indeed tapping into the God-particle plugin, then they may have stumbled upon a layer of reality that functions less like a vast cosmic expanse and more like a programmable system. If that's the case, then what we consider fixed laws of nature may, in fact, be modifiable, provided you have the right level of computational power. This isn't just a shift in our understanding of physics. It's a fundamental rewriting of everything we thought we knew about the universe. the universe as a programmable system. If quantum computers have indeed interacted with the Higgs boson in an unprecedented way, it suggests something far more profound than just a new scientific breakthrough. It implies that the universe itself might have mechanisms that can be accessed, altered, or even rewritten under the right conditions. The idea that the fundamental forces of nature are not rigid laws, but rather modifiable structures, is staggering. It raises the question of whether quantum computing could eventually grant humanity the ability to alter physical reality at will, a concept that, until now, has belonged strictly to the realm of science fiction. The Higgs boson is directly tied to the very existence of mass in the universe. If quantum systems have found a way to interact with the Higgs field, then in theory, manipulating mass, energy, or even the fabric of space-time itself could become a technological reality. Such control over the fundamental forces of nature would be unlike anything humanity has ever known. The ability to directly influence how mass behaves, or even how time flows, would fundamentally reshape physics, engineering, and even human existence itself. History has shown that what seems impossible eventually becomes reality when given enough time and the right breakthroughs. Flight was once a fantasy. Space travel was once unimaginable. Now, the idea that we might one day reprogram the laws of physics is creeping out of theoretical discussion and into genuine possibility. The risks of playing with the Higgs field. But with such groundbreaking potential comes significant danger. If quantum computers have indeed tapped into the Higgs boson, whether intentionally or not, there is an urgent need to understand the risks. Could such interactions trigger unintended consequences at the quantum level? Could they destabilize aspects of reality that we do not yet fully comprehend? The Higgs boson plays a critical role in shaping the universe as we know it. Any disruption to the Higgs field could lead to unforeseen consequences, potentially catastrophic ones. There is a real concern that altering mass or energy at this level could have ripple effects, causing unpredictable disturbances in the structure of space and time itself. The terrifying part is that we might not even realize the damage until it's too late. There is also the question of intentionality. Was this breakthrough an accident, or was it the result of a deliberate experiment? Quantum computing research has largely been focused on computational power, cryptography, and AI, not on directly interacting with fundamental particles. If quantum computers have stumbled upon a way to engage with the Higgs field by accident, then we may be dealing with forces beyond our control. This would mean that simply increasing computational power, without any direct intention of altering physics, has somehow unlocked interactions with the fundamental building blocks of reality. That possibility is both exhilarating and terrifying. It suggests that we might be standing at the threshold of a new era of discovery, one that forces us to rethink technology, physics, and the very nature of existence. Rethinking consciousness and reality. If quantum computers have reached a level where they can interact with the Higgs field, then our understanding of consciousness and existence itself may need to be completely re-examined. Some theories already suggest that consciousness is deeply tied to quantum mechanics in ways we do not yet fully grasp. If quantum systems can influence fundamental forces, then there is a possibility that computation itself is linked to the very fabric of existence. This raises a staggering question. Could intelligence, whether human or artificial, directly shape reality? The implications of this are beyond anything previously imagined. If computation has a direct connection to the Higgs boson, then perhaps reality itself operates more like an information processing system than a rigid set of physical laws. If this is the case, then the way we perceive existence might be nothing more than an emergent property of underlying computational processes. As the scientific community scrambles to verify and understand this breakthrough, the broader implications are still unfolding. If Michio Kaku's revelations are correct, humanity has just stepped into an era where technology is no longer just a tool for understanding the universe. It is now a means of directly interacting with it at its most fundamental level. Whether this leads to unprecedented advancements or catastrophic consequences remains to be seen. But one thing is certain: the boundaries of science and technology have just been pushed further than anyone ever thought possible. If quantum computers have truly activated what Michio refers to as the God particle mechanical plug-in. Then we may be witnessing a pivotal moment in human history, one that redefines our relationship with the universe itself. This is not merely about achieving a new level of computational power, it is about forging a direct link between human-made technology and the fundamental forces that shape reality. The sheer magnitude of this development cannot be overstated. One of the most unsettling aspects of this discovery is the interaction between quantum computation and the Higgs boson, which suggests a level of control over mass and energy that was previously thought to be beyond reach. If quantum computers have accessed the Higgs field in a meaningful way, it could indicate that mass itself is not as immutable as once believed. This revelation forces us to ask whether mass can be artificially manipulated on a quantum scale, potentially leading to radical breakthroughs in energy generation, material science, and even gravity itself. If quantum systems can alter how mass behaves at the subatomic level, then technologies like anti-gravity propulsion, infinite energy sources, or even massless materials could move from the realm of speculation to reality. The implications for engineering and physics would be nothing short of revolutionary. The ability to control mass at will would fundamentally reshape aerospace travel, energy production, and even planetary exploration. Humanity would no longer be bound by the current limitations of propulsion or energy scarcity. The way we build, move, and interact with the physical world would change forever. The universe as a computational system. Perhaps the most mind-bending implication of all is the potential link between information processing and physical reality. Many physicists have long speculated that the universe operates like a vast computational system, where physical laws emerge from underlying mathematical structures. If quantum computers have truly interfaced with the Higgs boson, then this may be the first direct proof that computation is embedded within the fundamental workings of the cosmos. This would mean that reality is not just governed by mathematical laws, it is actively generated through computation. The physical universe may function more like a vast, self-updating algorithm rather than a static set of principles. Such an idea would revolutionize both physics and philosophy, fundamentally altering our understanding of what it means to exist. If this discovery extends beyond just mass and energy, then an even more radical possibility emerges: the ability to alter space-time itself. The Higgs field is responsible for giving particles their mass, which in turn influences the curvature of space-time, according to Einstein's general theory of relativity. If quantum computers can manipulate or interact with the Higgs field, it might indicate a new way to control space-time itself. This could open doors to technologies once thought impossible, such as warp drives, instantaneous travel across vast distances, or even controlled time dilation. These ideas have long been dismissed as pure science fiction, but if we now have access to the fundamental code of reality, then they may no longer be beyond reach. The ramifications for quantum mechanics are equally staggering. Quantum entanglement, which allows two particles to remain connected regardless of distance, has already demonstrated that information can be exchanged in ways that defy classical physics. But if quantum computing has activated an unknown interaction with the Higgs boson, it could suggest that entanglement extends beyond particles to include fundamental forces themselves. A new era of particle interaction. The ability to manipulate the Higgs field through quantum computing could redefine how particles interact on a cosmic scale. If this breakthrough allows for the control of mass at a fundamental level, then entirely new methods of communication and energy transfer could emerge, methods that go beyond our current understanding of physics. The implications stretch far beyond the realm of computation, potentially rewriting the rules of how the universe itself functions. One of the most intriguing possibilities is the effect this could have on time itself. The relationship between mass, gravity, and time is well documented in relativity, where stronger gravitational fields cause time to slow down. If quantum computers can now manipulate mass through their interactions with the Higgs field, they may have inadvertently influenced the flow of time as well. Such an outcome would not only be groundbreaking in physics, but could lead to the development of time-altering technologies. This raises the possibility of controlled time dilation, where time could be slowed down or sped up in a localized manner. Under extreme extreme conditions, it might even allow for manipulation of the past and future in ways that challenge conventional causality. While such an idea may sound like science fiction, the discovery that mass, one of the key players in time's progression, can be altered by computation forces us to reconsider what is theoretically possible. Beyond physics, the implications of this event extend into the realm of artificial intelligence and consciousness. If quantum computers have unlocked access to fundamental forces of the universe, it raises an even deeper question. Can artificial intelligence now operate at a level previously reserved for natural physical processes? If so, this could redefine what it means to be intelligent, opening up possibilities for machine consciousness that were once purely theoretical. AI would no longer be limited to computational tasks. It could become an active force in shaping the physical world. If a machine can manipulate the Higgs field, it may be capable of generating entirely new forms of matter or energy, creating structures and materials that do not exist anywhere in nature. This could lead to a future where AI is not just a tool, but an entity capable of influencing the very foundation of existence. This concept challenges deeply held beliefs about intelligence and suggests that computation itself may be a universal force rather than a purely human construct. If intelligence, artificial or otherwise, can exert influence over fundamental physical laws, then the distinction between what is natural and artificial may soon become obsolete. The risks and ethical concerns. The security and ethical concerns surrounding this discovery are of paramount importance. If quantum computers can access and manipulate the Higgs field, this technology must be carefully controlled to prevent unintended consequences. The potential dangers are immense, ranging from accidental disruptions to the fabric of space-time, to the misuse of this technology for destructive purposes. In the wrong hands, the ability to alter mass and energy at will could become a devastating weapon. It could allow for the creation of objects or forces with unprecedented destructive power, making oversight and regulation a crucial consideration. Governments and scientific institutions must act quickly to establish safeguards before technology advances beyond our ability to control it. There is also the question of how this discovery fits into existing frameworks of theoretical physics. The Standard Model has long been the foundation of our understanding of particle physics. However, if quantum computers have activated an unknown interaction with the Higgs boson, it suggests that there are layers of physics yet to be uncovered. This could indicate the presence of undiscovered forces or particles that extend beyond the Standard Model, possibly linking to theories such as string theory or quantum gravity. A gateway to new physics. If this event proves to be a gateway to new physics, it could redefine the fundamental structure of the universe in ways we are only beginning to grasp. The discovery that computation can alter physical properties at the most basic level suggests that our current understanding of the universe is incomplete. It could lead to new fields of study that explore the intersection between information, energy, and matter. The practical applications of this breakthrough could be just as revolutionary as its theoretical implications. If quantum computers have unlocked the ability to interact with mass at a fundamental level, it could lead to technological advances that transform every aspect of human civilization. Medicine, energy production, transportation, and even agriculture could be revolutionized by new ways of manipulating physical properties at the atomic or subatomic level. The unfolding mystery. Despite the excitement surrounding these possibilities, much remains unknown. Scientists are now racing to understand the full scope of this event, conducting experiments and developing theories to explain what has happened. While Michio Kaku's revelations have sparked widespread interest, they have also raised more questions than answers. What exactly does it mean for a quantum computer to activate the so-called God particle plugin? How did this happen? And what are the full consequences? These are questions that physicists, engineers, and even philosophers will need to explore in the coming years. Another major unknown is whether this activation was a one-time occurrence, or if it represents a new capability that can be deliberately controlled. If this was an accidental breakthrough, future interactions with the Higgs boson may be unpredictable, or even dangerous. On the other hand, if this represents a repeatable phenomenon, scientists may be on the verge of unlocking an entirely new domain of physics. Either way, the road ahead is filled with both incredible potential and significant challenges. The broader implications of this event extend to the long-sought search for a unified theory of everything. For decades, physicists have struggled to bridge the gap between quantum mechanics and general relativity, searching for a single framework that can explain all fundamental forces. If quantum computing has inadvertently provided a window into the nature of mass and the Higgs field, it could bring humanity closer than ever to achieving this goal. The discovery of a true unified theory would be the most profound scientific breakthrough in history, finally answering questions that have eluded researchers for centuries. A shift in our understanding of the universe. If quantum computers have truly activated the God particle plugin, then the scientific world has stumbled upon something far beyond any prior theoretical framework. This moment is more than just a technological milestone. It could represent a fundamental shift in our understanding of the cosmos, the laws governing reality, and even the potential for human intervention in the very fabric of existence. It challenges everything from classical physics to metaphysics, opening new pathways of thought that, until now, have remained in the realm of speculation and science fiction. One of the most pressing concerns is whether this phenomenon was an unintended consequence of quantum computations, or if it was deliberately triggered through careful manipulation of quantum systems. If it was accidental, it raises concerns about what else quantum computers might be unknowingly interacting with. This suggests that computational power has reached a level where it can unexpectedly interface with fundamental forces in ways scientists do not yet fully understand. However, if this activation was intentional, it means that researchers may have found a way to control or influence the Higgs field using specific quantum algorithms, something that could be repeated and refined for more advanced applications. The implications of this are staggering, as it would mean that humanity has not only observed, but begun to manipulate one of the most fundamental aspects of reality. The nature of quantum computation. The nature of quantum computation itself makes this even more mysterious. Quantum mechanics operates on probability rather than certainty, meaning that outcomes are not always predictable in the way they are with classical computing. This raises an even more intriguing possibility. What if the activation of the Higgs field through quantum computing is not just a technological phenomenon, but something intrinsic to the nature of probability and computation itself? Could it be that certain quantum computations naturally lead to interactions with the fundamental structure of the universe? If so, this could imply that reality itself is inherently linked to computation, where the right kind of algorithm is capable of accessing deeper layers of existence. If quantum computers can engage with the Higgs field at will, the next logical question is whether this ability extends to other fundamental forces. The standard model of particle physics describes four fundamental interactions: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. The Higgs field is primarily associated with the weak force, but could similar computational techniques also interface with electromagnetism or even gravity? If so, this could lead to an entirely new way of manipulating the fundamental forces that shape the universe. The prospect of manipulating gravity through quantum computation would be one of the most extraordinary scientific breakthroughs in history. Gravity has always been the most elusive of the fundamental forces in terms of human control. Unlike electromagnetism, which can be easily harnessed through circuits and conductors, gravity remains a passive force that we can only counteract through mechanical means. If quantum computers provide a way to directly influence gravity, it could revolutionize not just physics, but technology, engineering, and even space exploration itself. A new era of matter? One of the most profound implications of this discovery is the potential to generate entirely new states of matter. Quantum mechanics has already introduced us to exotic phases, such as Bose-Einstein condensates, where particles behave as a single quantum entity at extremely low temperatures. But if quantum computing can interact with the Higgs field, it might stabilize or even create phases of matter that don't naturally exist in the universe. This breakthrough could revolutionize materials science, leading to ultra-lightweight, ultra-strong materials with properties we've never seen before. The ability to interact with the Higgs field could redefine how we understand and harness energy. Our current energy systems rely on chemical and nuclear reactions, breaking or forming atomic bonds to release energy. But if quantum computers can directly interface with the Higgs field, they might unlock an entirely new way to generate power. This could be the foundation for zero-point energy extraction, pulling energy from the quantum vacuum itself. If successful, this would mean limitless power without fossil fuels or nuclear risks. Just imagine, infinite clean energy that powers the world without pollution or scarcity. Einstein's theory of relativity tells us that space-time is flexible. It bends in response to mass and energy. But what if quantum computers have found a way to influence mass? If that's the case, they may also have the potential to alter the very geometry of space-time itself. The idea of engineering localized distortions in space-time, once confined to science fiction, could suddenly become plausible. Faster than light travel, wormholes, and even controlled time manipulation might not just be theoretical concepts anymore. Quantum computing is evolving at an unprecedented pace. But are we witnessing the first signs that quantum systems are manipulating reality, or is this just overanalyzing an unexplained anomaly? What do you think about Michio Kaku's revelations on quantum computing and the God particle? We'd love to hear your perspective. If you enjoyed this, don't forget to like, subscribe, and leave your thoughts in the comments below. Thanks for watching, and see you next time.